Hello, welcome to another session of the Houdini training. My name is Gianvito Serra, and today we're going to learn a bit about debugging digital assets and some work. What I'm going to be showing here is just a few workflows that work for me in situations where a digital asset may not work or may not work as expected or is straight up breaking, okay? There is obviously multiple ways how you can go about debugging when a digital asset is broken, and you yourself will learn what actually works best for you. What I like to do with these particular tutorials is just show you a few things that have worked for me. Okay, so the first thing we'd like to do here is we'll start with our column generator. The first thing we'd like to do is to actually break something. Okay, so what I like to do is to actually simulate an error or emulate what happens when we create an error, and then just step towards into a few things that we can do to actually resolve the error. Okay, so let's go ahead and actually go inside. Now, just as a little reminder, remember that while you are inside of a subnet or a digital asset, you won't be able to edit it until you allow editing of content. Okay, because otherwise the digital asset is locked and nothing can be changed. Okay, so if you remember from the last tutorial, the way how we go about doing this is by right-clicking on the node and saying allow editing of content. Okay, and then the text goes red, which means that now we can go inside of our digital asset and change it. Very cool. Okay, so for the purposes of this tutorial, I'm going to go ahead and create an error. Okay, so what I'm going to do is I'm going to go inside of the subnet that creates the grooves, okay, which is basically what creates this shape right here. And I'm going to break one of the nodes. Okay, so I'm going to select this node and I'm going to put an invalid expression on the bias. So just something that makes absolutely no sense to Houdini, okay? So look what happens when the first time that you introduce an error in Houdini. Okay, you will notice that what ends up happening is that the nodes in Houdini go red. Okay, the moment that the error happens, we get a red stream of nodes, which are nodes that are broken. If you go back out of the network, you will notice that the red stream of nodes goes down all the way to the node that finally displays the geometry. Okay, however, you will notice that we still have a few nodes that don't have errors, and so let me explain a bit of what's going on here. Okay, and I'm going to make this so that we can see this a little bit bigger. The way how Houdini cooks its dependency graph is not from top to bottom, like a lot of people think, but from bottom to top. Okay, the reason why they do this is because they have to resolve the way how the cooking mechanism works is that it works on demand. Okay. Nodes that do not have to cook will not actually will not actually be cooked unless the node unless Houdini has to cook them. Okay, so for example, if the Houdini wants to render something on the screen, it will ask the display node for its geometry. Okay, then in turn the display node will ask for the node before that for the output of its geometry, in this case the color. Okay, then the color, in order to be able to color the geometry, asks the node before that for the geometry to color, right? Which in this case is the normal generation. And the normal generation asks for the node before that for the geometry to create normal, so in this case the transform, and so on and so forth. Okay, so we keep basically walking back. Okay. You ask, why does this even make sense? Well, look, for example, in this particular area where we have a switch, right? You will notice that we have a solid line and a dotted line. Okay, the dotted line is not getting even cooked, right? Because when Houdini is actually trying to figure out what needs to cook based on that demand, it is walking backwards, and then in this particular case, because a merge node is going both ways, going this way first and then this way, and then when it gets to the switch goes, well, not these two threads are not going to cook, only one of them will, right? So in this case, based on the dotted line, because of the choice that the user made, you can tell that we have to cook this thread and not this thread. Okay, so this node will never even cook. Okay, it's important for optimization, but also to correctly resolve these particular node networks. Okay, Now back to the error. So the reason why you see the error going this way and not here is because of that. In fact, when you get to the merge node, the thing to remember is that yes, the merge node is broken, but this node is not, because this node is not actually part of this particular thread, but this node it is, okay? The reason why the merge node is broken, in fact, is because one of its inputs is errored, okay? And so therefore we can very easily follow. We have very easily, what is really nice is that we have a very nice breadcrumb trail to figure out where everything broke, okay? So the first thing to do is to look at the red nodes and trace back to where the error first originated. So if we walk back on our network, we'll notice that the first node that actually has an error is subnet create group curve, okay? One thing that is neat is that you will notice that I can put the display flag on the merge node and the geometries that the merge node generates are still there, which is awesome. So look, so is the carve operation that we have here, and so is even the tube, okay? The reason why is because, again, this goes into the nature of being non-destructive. Houdini will, Houdini is never too late to change anything. It's one of the biggest strengths of the program, okay? Because the data is always being generated on the fly, at any point we can change anything, fix anything, and everything will go back to normal, okay? It goes for error. So whereas in most programs you are used to having to use undo multiple times to get back where you were, in Houdini that's generally not how you do. You can if you want, but generally what you do is you figure out what your problem was and you fix it, okay? Or you figure out what your change that you want to do is and you change it, okay? So let's go inside of this subnet to track a bit further into where the error is, okay? And then we can see that now the error is happening at this join node right here, okay? Cool, so if we click on the in node, you will notice that the in node is still working. The first join node is working, and even the first mirror node is actually working, right? So we actually have our half a groove here, okay? Moment that we get to the join node, then the geometry disappears, okay? One thing that is nice about Houdini is that it's very easy to tell when something is broken, because you will basically get no geometry on the screen, which is nice, okay? So now that we found the node that has a problem, we can now start looking into what's broken with it, okay? And obviously, from breaking it ourselves, we know what's broken, but let's see if we can figure it out by looking into the node information, okay? So the easiest way to tell immediately what the error is to middle mouse hold on a broken node and go to the very bottom of the label and see what the error is. So in this particular case, the error is that it's unable to evaluate an expression, and it gives you the path to the parameter that has the expression, okay? So if we look at the path is object go1, which you will see matches this right here, column generator tutorial 1, subnet create group curves. This is the subnet that we're on, okay? So the node should be here. Join mirror on edge is the node, okay? And the parameter is called bias. So if you look carefully here, join mirrored on edge is the node that we have selected right now. And we're looking for a parameter called bias. Well, here is a parameter called bias. And if you look at it here, it has a broken expression, okay? Cool. So all that we have to do to fix this problem is to simply fix the expression. The moment that we fix the expression, then you will notice that that's working, right? Cool. We don't even need an expression here, so we can go ahead and even right click on this and delete channels, which will make the expression go away. So awesome. That's very cool. Now we see the join operation working again. However, you will notice that there is error still on these nodes right here, right? And again, remember, the reason why is that is because we haven't asked Houdini to display them yet. Therefore, Houdini has not had to cook them. The last time that they were cooked, they had an error. The next time we force them to cook, they won't have an error, okay? So all that we have to do is to put the display flag on the output node and watch. Now all of these guys clear out from that error, and we can see the output of this, right? Likewise, if we press U to go up, you will notice that we still have an error here. Okay, but that's again because our display flag is here and we haven't requested to render to cook this guy. So when we put the flag here, you will notice that now it's not broken here. And as we even step forward on the nodes, Houdini will go ahead and cook the nodes and clear the error automatically for us. All that we really have to do is to go to the last node on the chain, and then everything is working back the way it was. Cool. Wonderful. Now, another thing that can sometimes happen is that you may not have an error, but you may have, for example, a warning. Okay? A warning is, unlike an error, it will actually display the geometry and render the geometry. It's just a means to give you a little information that you may be doing something that you may be not as you expect, okay? So, just to demonstrate that, I am going to go ahead and instead of creating the normals down here, I'm going to create the normals up here, okay? So let's go ahead and put a normal operator right here, which creates normals. You'll notice that when I did that, all of a sudden the caps and columns merge node has a warning on it, okay? So let's go ahead and actually make this active. Oh, and look at that. We now have a white cap and a black cap down here, okay? So if we look at this and we middle mouse, just like we do with errors, we can see what the warning is down here. So the warning is just telling you that there is a mismatch of attributes of the inputs, and some attributes values may not be initialized to expected values, okay? In this case, what it's referring to attribute is referring at the normals, okay? So what it's saying is that this thread on the left has normals, this thread on the right does not have normals. As a result, what happens is that Houdini has to create something for this in order to be able to render, right? So Houdini goes ahead and create normals, but only for the ones on the left, the stuff that is coming from the left, the stuff that is coming from the right. It's not that it does not have normals, it has normals that are 0 length. They're basically initialized to 0. So if we look, for example, here, and we look at the spreadsheet, you will notice that if we look at the vertices, we have normals for most of them, but then we have a lot of vertices which have, it's a little bit hard to tell here because of how they are actually ordered, but we have a lot of vertices which basically have no normals, okay, which is the issue that we're running into, okay? The reason why I put the normal operation here instead of putting the normal operation here is because of avoid that, you know. Likewise, you can also avoid this problem by simply putting another normal operator here. And now watch, the warning goes away. Everything has normals. And if we middle mouse, we have no warning anymore, okay? My particular solution for this was just to put a normal operator here again, because then I don't have to do it twice, okay? So I'm going to delete these guys. And then we're back to the way we were, okay? Very cool. All right, so that covers errors and that covers warnings, okay? We also saw how we can use the display flag to step through different nodes and actually be able to get an idea of how the network is working, okay? Another thing that is very useful to remember is that we can also use the template flag to see any part of a network at any point, okay? So say, for example, I wanted to take a look at, I was looking at my, this guy, where I'm actually looking at the creation of this, but I wanted to see while I'm working on this, how the caps are looking or how they're coming together, okay? While I'm actually doing changes here. So we can simply do that by clicking on this, and then we can actually see it here. See that? That just gives us a reference so that we can see, you know, any part of a network while we're actually working on another part of a network, okay? It's very useful, for example, if we're looking at the tube, but we still want to see what the caps look like, okay? And we can even come here and adjust the values on the tube, like for example the radio, like for example the height, and see that my template meshes cook just like the regular meshes, okay? They're very useful to actually use template meshes because they give you a lot of visibility to what's going on. Okay, we can even, if you control click on the pin flag on a node, it will also allow you to have multiple templates, but you can even have templates which are shaded. Okay, so this is still template, but it's actually fully shaded, so that we can just simply see it as if they were merged together. Okay, to take the template flags off, just simply click it off, and that will actually make the little arrows go away on that. Okay, very cool. Another useful thing that we can do is that we can actually have multiple viewers at the same time, focus on different areas of the net. For example, I can, while I'm actually looking at this here, I can also come over here and see, for example, what this copy node looks like in a different window. So I can right click on it and then look for preview window up here, okay? And that pops a different viewer that we can use to see the column at different states in the network. Okay, so now we see the final state, and then we see the intermediary step right here. And you will notice that as I actually go to here and I play with my values, this actually modifies on both viewports of Houdini, not just on one. Okay, this is really useful technique to be able to see multiple results of your operations, right? A lot of times you want to see what you're working on and you want to see the result at the same time, and this is one great way to do it. Okay, you can also, if you want to do it very easily, if you like the view that you have here, you can lock this view so that no matter what node is active, no matter what context you're on, you will always only see what that view is set to. Okay, this is the pinning. You can also pin a parameter window. You notice that the parameter window changes every time that you pick a node. Well, we can actually pick a node that we like and then pin it, and then that will actually keep them from switching at any point. Okay. Last, I like to show a very useful tool inside of Houdini for not even just debugging, but even to get a sense of like what are the fastest parts of your operator and the slowest parts of your operator. Okay, and that is the performance monitor. Okay, so let's go back out for a second. All right, to our column and our digital asset, and if we go to window and we go to performance monitor, it should be around the bottom, it loads this very useful window, this little window, which allows us to check our performance. Okay, I'm going to adjust things a little bit here so that you can see a bit of what's going on here. And the way how this works is that at any point I can start recording all my actions in the performance monitor and start seeing how much memory things are taking, how much time things are taking to cook, and so on and so forth. So let me just demonstrate that. Okay, so if I hit record, nothing happens at first. Okay, now watch, the moment that I actually move my viewport, Houdini starts recording how much time I'm actually spending drawing this column, okay, on the viewport. We can also clear the view at any point to start fresh. What I like to show is if we select this node, let me go ahead and clear that, and change a parameter, what actually ends up happening. Okay, so one tip that I'll give you here is to, if you really want to see how your whole digital asset performs, is to actually do it on to actually change an operation which causes the full graph to change. Okay, if you guys remember, the tube node is the first one that actually processes this graph. Okay, so if we come here and change the height to 101, this is going to cause the whole dependency graph, or the majority of it rather, to actually cook. Okay, so we'll do that. Watch what happens. All right, and I'm gonna go ahead and actually stop it for a second so that we can see what's going on here. You will notice that now I have a list of all my nodes in my network. Okay, I still see the viewport cook in here, so we're gonna hide the viewport because we don't care about those right now. We just wanna see this. So you can see all your nodes inside of a column generator, and you can see how much each one of them are taking. So for example, In this particular case, you'll notice that the fuse node is the one that is taking the most time. It's like 10, it's like 0.010 seconds. So it's still very, very fast. But you can immediately tell which one is the slowest, okay? Generating normals is also the net slowest, is 0.006 seconds, okay? We can see in here and you can even open the subnets and see what items in the subnet add up to the total cost of a subnet, okay? We also have the nodes now color-coded with little auras, so you can see, for example, which nodes are the ones that are actually taking the most time. So sure enough, here is the fuse node, which is taking the longest to actually cook, okay, and it's red. In some cases, you may want to replace the fuse operation with a different operation, which may be faster. In this case, I mean, that's not that slow, so that's okay. So very cool. And when we're done, we can simply close the performance monitor, okay? It's a little bit of a bug with the auras. If you get stuck with the auras and you don't want to see them, you can always reopen the performance monitor and then hit record again, clear it, and then just stop it. And then that's gonna stop the auras, okay? One last thing about the performance monitor, when you do a performance monitor, you can always come here and profile and actually save it. And then you can keep the hand if you need to actually show it to somebody, or if you need to reference after you do some optimizations, what your timings used to be versus your timings are now, okay? Awesome. Very cool. All right, but that should cover for this lesson. Thank you for watching, and we'll see you in the next lesson.